Okay, the meaning of exponential class, so that's mean your fx theta, it can be written as exponential class. Ini exponential exp stand for exponential lah Exponential, we have p theta, kx, hx, q theta. So x belong to s, macam sample space lah. So you have exponential p theta, kx plus hx plus q theta. If we can write our PDF or PMF in terms of exponential class, so we can find a complete family. Okay, complete family for your PDF. Alternative, first we use definition. Second, if the PDF or PMF can be written in terms of exponential class, so you can use also that one to find a complete family. Okay, so S here is your support, okay, support of X. So that's mean your, let's say, let's say your X is between 0 and 1. So this is your support lah. Support maksudnya range lah, range of X range of X, support of X. Okay. So a probability density function given in equation, okay, equation 1 yang tadi tu, exponential family tadi, is said to be a member of the regular exponential class. Okay, regular exponential class if satisfy these three conditions. They must satisfy these three conditions, then we will say that it is a member of the regular exponential class. So first tu, okay, S ni, S the support of X. So the support of X does not depend upon theta. So in your range, okay, range of X cannot have theta. Okay, support of X does not depend upon theta. So second properties, our p theta, nanti kita find what is your p theta, is a non-trivial continuous function of theta belong to omega. Okay, first you need to know what is the definition of trivial, non-trivial. So kalau normally trivial, that's mean p theta. Let's say lah, kalau trivial, that is trivial solution lah, trivial solution, non-trivial solution. So kalau trivial, that's mean, we check definition dia, trivial nanti. So normally you can have X equals to 0. But if you have non-trivial, normally your X bukan 0 lah. The answer is not 0 lah. The solution is not 0. Okay. So in this case, P theta is a non-trivial continuous function. So the third property is X is a continuous random variable. If your X is a continuous random variable, then we will have K prime X. So that means we already have your KX. Lepas tu kita take derivative K prime. K prime does not equal to 0 and your HX is a continuous function. So tapi kalau dia discrete, X is discrete, then your KX is again non-trivial lah. Okay. Nanti your homework is to find what is the meaning of trivial. Okay, cuba carilah. Okay. Trivial dengan and also non-trivial. Apa maksud dia? Okay, ataupun if you already learn this one, is okay lah in your maths ke apa ke. Okay. So trivial and non-trivial function. So if these properties, these three properties is satisfied, then we can define our probability density function is a member of the regular exponential class. Okay, kalau dia satisfy tiga condition. First, the support of X does not depend upon theta. Your range does not include theta. P theta is a non-trivial continuous function. If X is continuous, then you can find K prime X to make sure K prime X does not equals to 0. And also your H is a continuous function. And if it's a discrete random variable, so your Ks is a non-trivial function of X belong to your support, your range. Okay. So let's say we have this example. Okay, this example, suppose that X is distributed as normal distribution, mean 0, variance theta. So with probability density function, we given like this fx theta 1 over square root 2 pi theta exponential negative x square over 2 theta. Okay, we want to write this exponential distribution in terms of, this normal distribution in terms of exponential case. Okay, we want to verify that fx theta is a regular case of the exponential distribution. So first, we will try to write this PDF in terms of exponential case. Yeah. Okay, before that, okay. So you need to verify your fx theta is a regular case of exponential distribution. So we have 1 over square root 2 pi theta exponential negative x square over 2 theta. So if we write this one in terms of exponential case, so that means we will have exponential negative x square over 2 theta minus ln square root 2 pi theta. Okay, you have your fx theta is 1 over square root 2 pi theta exponential negative x square over 2 theta. Okay, so if we want to write in terms of all this one, the function in terms of exponential, so that means you have negative x square over 2 theta. Yeah. So let's say we have exponential negative x square over 2 theta. So if we want to write this one in terms of exponential distribution, so you have plus ln 1 minus ln square root 2 pi theta. Okay. So in here, our ln 1 is equals to 0. So that's why we only have exponential negative x square over 2 theta minus ln square root 2 pi theta. Okay. So that is the exponential case. Okay, now we will check 3 conditions. So the first condition, the support of x does not depend upon theta. So since your exponential distribution, okay, if you refer back exponential distribution, okay, your x is from, exponential, sorry. Your normal distribution, your x is from minus infinity up to infinity. So this interval does not depend upon theta. So it satisfies the first condition. The support of x does not depend upon theta since we have minus infinity less than x less than infinity. Your range, eh? Second, we will try to write down in terms of exponential. Okay, exponential p theta kx plus q theta plus hx. Okay, so now if you compare, your p theta is negative 1 over 2 theta. Okay, your p theta is negative 1 over 2 theta. Yeah, your kx is equals to x square. Kx is equals to x square. Your q theta now is negative ln square root 2 pi theta. Okay, and then your hx is equals to 0. Okay, so again, your p theta is minus 1 over 2 theta is a non-trivial continuous function since we didn't get p theta is equals to 0. Okay, so since your p theta is not 0, so that means it is a non-trivial continuous function. And then the last one, your kx is equals to x square 2 theta, and then in this case we don't have hx. Hx is equal to 0 lah. That means if you have exponential 0, it becomes 1. So actually, so this one, so we just write hx is equal to 0. So if we differentiate our kx, k prime x, so it's become 2x. If k prime x is equal to 2x, which is just not 0. So since it satisfies these three conditions, we can state that your fx theta is a regular case of exponential class family. Okay, so itu three condition Okay. So that's mean, yeah. So let's say our first example tadi, example, you have a normal distribution, mean 0 variance theta. So you have 1 over square root 2 pi theta exponential negative x square over 2 theta. We need to verify whether our fx theta is a regular case of exponential distribution. Okay, so if we need to verify whether fx theta is a regular case of exponential distribution, so that's mean, yeah, so S is the support of x which is does not depend upon theta. Second, P theta is a non-trivial continuous function. So again, need to check trivial and non-trivial definition apa. So x is a continuous random variable and each of k prime x does not equal to 0 and your hx is a continuous function. Okay, if we refer back to the example for normal distribution, we already have your fx theta. Okay, fx theta exponential negative x square over 2 theta minus ln square root 2 pi theta. So it can be written as this one, fx theta 1 over square root 2 pi theta exponential, it's fine. So exponential negative x square over 2 theta ln 1 minus ln square root 2 pi theta. So since our ln 1 is 0, so it gives you just this one. Okay, now we check whether it satisfies the properties for exponential case. Okay, so first, support of x does not depend upon theta. Your x is between minus infinity up to infinity. Second, your p theta, which is minus 1 over 2 theta, is a non-trivial continuous function. Okay, because your p theta is not equal to 0. Second, third one, your kx is equals to x square. Kx, x square. So kalau kita differentiate, you will get 2x. K prime is 2x which is does not equal to 0. So it satisfies these three conditions. So by the definition, your fx theta is a regular case of the exponential distribution. Okay.